Okay, this is going to be a quick overview of the X-ray viewer application that is working with gVXR library written by Frank Vidal. So to start with, there's a 3D environment. If I put the field of view to the correct field of view, that has, as we can see, a LabCT scanner with an appropriate interface for doing CT scans and setting up sample positions and all sorts. I'll go over that in a minute. So when using the application, the first thing you're going to want to do is open the scanner door to load a sample. You'll see if you can select something, because when you put the cursor on it, you'll get a green highlight arrow that looks like that. So the same goes for the screen, this and this, which doesn't do anything. So if I load a sample up by hitting E on that, we can add a new sample. We will need a path to the sample. I might have a path here, yes I do. And then we can set some properties. So if I just make this iron, because this is an element, this is ignored. But obviously if I change this to a compound or a mixture, then the density does need to be set to whatever you want it for. For an element, this can be anything and it will have absolutely no effect on the output. So once you've put this data in, assuming it's all correct, and you click close, nothing will happen. The sample won't be loaded, won't be displayed there yet, because that's something that's being worked on. It's quite difficult to load a mesh in dynamically in Unreal Engine. So once I close the door, I can power on the scanner. We still get radiation warning here. We have these values here calculated from the image that will be displayed if I move the sample up into the field of view, and there we go. So we have the sample into position, and I can position that sample using the on-screen controls here, and we can see that the sample platter is moving around inside the scanner to replicate the position. So I've got a couple of options, positioning options and rotation options, and the data for that will be displayed up here. So I can change the beam type. This is just an option that is available in the gVXR library, and I thought it would be interesting to implement that. So that just changes it from a parallel source or a point source. So obviously a point source, you've got a perspective, and a parallel source, it's a straight line. So it's just a an orthographic projection. Can change the energy level as well. This is at 80 kilo electron volts. For iron, normally you get quite a good image, about 250. So you can see there, that's a significantly better X-ray image. I can do some processing on this output image at the moment. This is linear, but I can change that to gamma corrected. It will have no difference at the moment because it's just 1, but if we increase that, we get a change in contrast of the image, or decrease it as well, we'll get different contrast. So I'll put it about 1.2. At the same time, we've also got a scale here that just gives you an idea of the energy levels that each colour represents. So the darker is going to be a much lower incident energy on the detector, so higher absorption through the material. There is also a log scale, which displays the image with a logarithmic gradient with the base 10, so we can see here as well, like so. I'm going to put this back to linear for now. There's a few other options, so we can save the output image, and this will just save a single raw image for the current configuration setup for the scanner. Or we can run a CT scan. So what this will do is it will start from the position here, and it will run a CT scan for the range that you've set here. You can just click and drag on here. So if I set this to be 210, and I want to go every 10 degrees, so we'll go for 21 images, if I can get this set correctly. No, I'll go closer to the screen, then it might work. There we go. Okay, so when I save this, this will create a new folder, and we'll get a new image. So you should see when I click this, There we go, that does the scan. There we go, it's now done. So with that scan complete, I can find that. It will be saved like this. It will give the date. You'll get the images, the raw output data saved like this, and some metadata that will help with recreating that if you wanted to create a volume from the CT scan. And this will give you all of the information that should be necessary. On a side note of a couple of extra sort of quality of life things, it's currently switched on. If I open the door, notice that the radiation warning's gone off. It has powered off. If I move the sample around, nothing will update, so I can hold that and you see I'm moving it all the way back there, but nothing's changing. If I close the door, okay, well actually before I do that, if I try and power it on, nothing happens, it won't work because the door's open. So if I close the door and now turn on the power, the image will immediately update. There we go. So I'm just going to move that back so it's in a better position. So there are in works as adding some keyboard shortcuts for moving samples around, because it can be a bit difficult to look here, to see the changes in real time. But for now, this is what is provided, and obviously the environment is also provided with a nice light switch over here, if you are one of those researchers that likes to work in the dark. And I've now got to turn it back on and I can't see it.